Hi guys, we're going to start 5.3, which is inequalities in one triangle. So let's first look at these key concepts at the beginning. So these key concepts say properties of inequality for real numbers. The following properties are true for any real number a, b, and c. And what they mean by this means that a, b, and c could be like 1, 5, and 10, any type of real number, so nothing imaginary. The first property is comparison property of inequality. So this says A is less than B, A is equal to B, or A is greater than B. Transitive property of inequality. If A is less than B and B is less than C, then A is less than C. This makes sense because these two outside ones, right, form this statement. And similarly, A greater than B and B greater than C, then A is greater than C. Same concept here. Addition property of inequality. If A is greater than B, then A plus C is greater than B plus C. If A is less than B, then A plus C is less than B plus C. And then lastly, the subtraction property. If A is greater than B, then A minus C is greater than B minus C. And if A is less than B, then A minus C is less than B minus C. Okay, so let's go ahead and look at the first theorem here. We have exterior angle inequality. So the measure of an exterior angle of a triangle is greater than the measure of either of its corresponding remote interior angles. For example, the measure of angle A is greater than the measure of angle, the measure of angle 1 is greater than the measure of angle A. So this angle here is greater than this angle. And also the measure of angle 1 is also greater than the measure of angle B. Okay? So we're going to use that theorem and those properties of inequalities to solve example 1. Example 1 says use the exterior angle inequality theorem to list all of the angles that satisfy the following condition. Measures less than measure 7. Okay, so here's measure 7. We have to list all of the ones that are less than measure 7. So all the ones that are going to be less than measure 7 is going to be measure 4 and measure 5. So measure 4 and measure 5 are inside of the triangle, meaning they're going to be less than that outside measure. So measure 4 and measure 5. Let me just make sure there's no other ones. Okay, and then also measure 1 and measure 2. Measure 1 and measure 2. So measure of angle 1, angle 2, angle 4, and measure of angle 5 are all less than measure of angle 7. Okay, now let's look at the measures greater than measure 6. I'm going to change my color. The measures greater than the angle of measure 6 is going to be 3 and 8. So here's 3 and here's 8. So the measure of angle 3 and the measure of angle 8 are greater than the measure of angle 6. And of course, this is based off of those theorems. We have an inside angle and then our outside angles. Okay, let's look at the next theorem. We have if one side of a triangle is longer than the other side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. So if we look at our example, xy, so xy is here, is greater than yz. So the measure of angle z, so right here, is greater than the measure of angle x. Okay. The next theorem says if one angle of a triangle has a greater measure than another angle, then the side opposite the greater angle is longer than the side opposite the lesser angle. So the measure of angle J, which is 110, is greater than the measure of angle K, which is 45. So that means the measure of line segment KL is greater than line segment JL. So opposite those angles. So let's use these theorems to work on example 2 and example 3. Example 2 says list the angles of triangle PQR in order from smallest to largest. So remember, since the sides correspond to the angle, look at all these angles here. So that means the smallest angle is going to reflect the opposite of the smallest side. So this is angle Q is less than angle, I'm going to do measure of angle. Measure an angle R is less than measure of angle P. Because if we look at the opposite things, the opposite side of Q is 7.5, the opposite side of R is 8.8, and the opposite side of P is 9.1. So this makes sense. So that means this is our answer. Okay, let's look at triangle FGH. Label them from shortest to longest side. Well, first we need to find the side, we need to find the angle F here. So in order to do that, we're going to add all these angles to 180 to find X. So 45 plus 56 plus X is equal to 180. If I subtract 45 and 56 to the other side, I get X is equal to, one moment, 79. So that means this angle of F is 79 degrees. And remember, we're looking at the opposite. So that's the opposite side. That's the opposite side. This one's the opposite side. So that means the shortest side is going to have the shortest angle. So that means the shortest side is FH, which is going to be less than HG, which will be less than the greatest side, which is going to be G. Or wait, I think I wrote that wrong. So this is FH, FG, and then GH. Because remember, it's the opposite side where the angle is at. And then if we were to write the angles there, we would see that we're correct because FH is looking at angle G, which is 45, which is less than angle H, which is 56, which is less than angle F, which is 79. So this is our answer. Okay, let's go ahead and continue on to example 4. Example 4 is a real world problem, and it's going to be our last example of section 3. So it says an interior designer uses triangulation to create depth in a client's living room. If the measure of angle B is less than the measure of angle A, which distance should be longer? The distance between the two lamps, or the distance from the lamp at B to the midpoint of the top of the artwork? Explain. So according to the theorem, in order for measure of angle B to be less than the measure of angle A, the length of the sides opposite angle B must be less than the length opposite of angle A. So let's write that. So measure of angle B is less than measure of angle A. So angle B is this side, so that means this side is smaller, and then measure of angle A, I'm going to say less small, because we don't know it in comparison to the other side. So then it wants to know which distance is longer, the distance between the two lamps, or the distance from lamp B to the midpoint of the top of the artwork, so here. Okay. Since AC is opposite to angle B and BC is opposite to angle A, then AC is less than BC, and BC is greater than AC. So BC, the distance between the lamps, must be greater than the distance from lamp B to the midpoint of top of the artwork. So AC is less than BC, and BC is greater than AC. So that means the distance between the lamps is greater. So this shows that the distance is greater between the two lamps. Okay, so this includes notes for 5.3.